There are three types of free fall. Dropping a ball from above the ground, throwing up a ball and letting it land on the same height, and throw down a ball from above the ground with some initial velocity. Today I'm going to show you throwing up a ball in the air and letting it land on the same height, and 6 different ways of finding the maximum height where the pen changes the direction. When pen go up, it changes the direction. I'm going to show you how to find that maximum height 6 different ways. First, translate this action. So this is the action. This is the action. What type of action it is? Free fall. To be more specific, throwing a ball upward with 15 meters per second. How can we translate it in equation? Well, let's try. -5 t square plus 15t. Alright, so 15 is the initial velocity. Now, if you don't see this equation represent the action, then I'll show you a different way, geometric way. Alright, let me show you the geometric way. Hopefully that one will make it obvious. Alright, so this is D, this is T. Alright, so now the ball was here initially, and the ball changes the direction here, and the ball landed exactly on the same height. So this is what is going on. So I'm going to call location 1, location 2, and location 3. So here's what I'm going to try to do. I'm going to find 1, 2, and 3. I'm going to find the displacement at every location, and I'm going to find the distance at every location. Yesterday I showed you find the time at every location. So the time every location is, quickly I'm going to remind you how to find the time at each and every location. So y is equal to -5t squared plus 15t. So let y is equal to 0. So -5t squared plus 15t. Alright, now if you factor out t, so you get -5t plus 15 is equal to 0. So t is equal to 0, -5t plus 15 is equal to 0, so t is equal to 3. Alright, so t is equal to 0 and t is equal to 3. So t at the maximum height has to be 1.5. Okay, so this is how you find the time, which I showed you yesterday, 6 different ways. Now today I'm going to show you 6 different ways of finding displacement. Okay, let's do the first way. Vf squared is Va squared plus 2AD. So I'm going to let Vf squared 0 because here the velocity is 0. V final is 0. Alright, so 0 is equal to Vi squared, which is 15 over here. Initial velocity is 15. So 15 squared plus 2. The A is -10 and D. So 0 is equal to 225 minus 20D. So D is equal to 225 over 20. So 225 over 20 is, let me see, 11.25. So 11.25. So maximum height, when velocity is 0, height is D max is 11.25. So I'm going to just go ahead and write 11.25 at location 2. What is the displacement at location 1? Displacement at location 1 is 0. What is the displacement at location 3? Displacement at location 3 is also 0 because the total displacement is 0. I'm going to prove it if you don't see it. Because the ball land exactly same height it is touched from. Look at the action again. Ball land exactly same height it is touched from. Okay, that's the reason it is. So I show you one way. So Bf squared is equal to Vi squared plus 2AD. Now let's show you the second way. Let's use the vertex formula. Vertex minus b over 2a is going to be quick solution. Minus b is what? B is 15, and 2 times A is minus 5. So minus 15 over minus 10. So 1.5. So vertex is 1.5. So x is 1.5. If x is 1.5, what is y? So let's plug that in. So y is equal to negative 5t squared plus 15t. So this is 1.5. You can call it x or you can call it t. Alright, so then y is minus 5, 1.5 squared plus 15, 1.5. And that gives you 11.25. So this is another way you can get 11.25. Alright, so you can use the vertex. Alright, what else you can do? Vertex plus position function. Plus position function. You can use the vertex plus position function. Thank you. Alright, now number 3. Let's see whether you can find it this way. D is equal to VAT plus half AT squared. So D is equal to VAT is 15, T is, make sure you write 1.5, not 3, because at 1.5 it changes the direction. So you must write 1.5 plus half, negative 10, 1.5 squared. And that gives you 11.25. Alright, so 3 way you found so far. Plus half AT squared. Now let's see whether we can find 4 way. Alright, so we're going to convert this one to VT graph, of course. If you do convert this one to VT graph, our initial velocity is 15, so this is 15. Our final velocity is negative 15. Negative 15. Why our final velocity? Because it's landed exactly same height as it's just from. Alright, so we need 3 points. The point number 1 is 0, 15. Point number 2 is 1.5, total time is 3. So point number 2 is 1.5, 1.5, 0. Alright, because at 1.5 velocity is 0. And point number 3 is 3, negative 15. At 3 seconds the velocity is negative 15. Alright, now I'm gonna connect these 3. Alright, connect these 3. Alright, so I have area on the top. Area on the top represent the displacement, the maximum height. Okay? And area on the bottom represent the other half of the parabola. That allow you to see the total, why the total displacement is 0. Okay? But let's first find the area right here, maximum height. So maximum height B max is equal to area is equal to half BH. So half B is how much? B is 1.5 and H is 15. So 11.25. So yeah, VT graph gonna give you the same thing. Number 4, VT graph. VT graph. Okay. Am I going to prove the prove why the displacement is 0? Well, if you add this one and this one, you're gonna get 0. Okay. So number 5, fifth way. Number 5th way. We're gonna use this formula. Average velocity. Now displacement is equal to average velocity times delta t. So average velocity VI plus VF is over 2 delta t. So the VI is 15 plus, why am I putting it in the parentheses? Nobody knows. Plus 0 over 2 and 1.5. So 7.5 times 1.5, I don't know. Let's see. I think 11.25 just to verify. 7.5 times. Yeah, 11.25. So this equation going to give you the same result. Alright, we can find the maximum displacement 5 different ways.